Let me review what we have discussed in the last class. So we basically started with a very simple example. That is, there's an entrepreneur who wants to finance his investment. And this guy has no money. So this guy would just try to get external money to finance his project. And then there are two ways to finance his projects. The first is he would use this all equity financing. And then the second is he could use a mixture of equity and debt. And our question is, will the entrepreneur has any preference, right? Let's say, will this entrepreneur prefer debt to equity, right? Or maybe he's just indifferent between using debt and equity. And the answer is, under the assumption of perfect capital market, the entrepreneur will be indifferent between using debt and using a mixture of debt and equity. The reason is, under these two different forms of financing, the entrepreneur will always raise the same amount of money. So he is being indifferent between these two alternatives. And then we would actually, this example will appear in this chapter for many more times. So it's important for us to remember, right? Remember these basic data points. So we know that this entrepreneur is taking on a project which pays you 1,400 if the economy is great, and 900 if the economy is weak. And if the entrepreneur fully uses equity to finance its project, then the value of the equity would be $1,000. Alternatively, if the entrepreneur decides to borrow $500, then the equity's value would be worth $500. And we also learned if a firm uses both debt and equity, then its equity is called levered equity. Okay, so let's start with the section on the effect of leverage on risk and return. Right, so we want to understand how leverage would affect the risk of equity. And we basically have seen from this table that if you have debt, then equity will become riskier, right? That's the basic result here. So how do you get this result from this table? Well, you can actually see that if you look at this row, then the difference between these two equity returns is just 50%. And then if you look at the levered equity, right? And you can see that the difference between this number and this number, right? It is actually 100%. So this basically tells you that the variation in the return of the levered equity is much larger compared with the variation in the return of the unlevered equity. Now we could also be more formal, right? We could think about systematic risk and risk premium. So basically, when you're talking about systematic risk and risk premium, then you're thinking you're thinking about the cost of capital in the framework of CAPM, right? So let's see what kind of systematic risks we have here. First, we know that the economy has two different kinds of scenarios. It could be strong and it could be weak, right? And then we know that debt always has a flat 5% return. So the return variation in the debt or the variation in the return of the debt is just zero, right? And we know that the variation in the return of the unlevered equity is 50%. So levered equity, it is 100%. So if you think about the variation or the return sensitivity, then you can see that levered equity has twice the return sensitivity compared with the unlevered equity. So this is actually equivalent to say that the beta of the levered equity is twice the beta of the unlevered equity, right? And then you can see that according to CAPM, if levered equity has twice the beta compared with the unlevered equity, then its risk premium, right? Then levered equity's risk premium would be twice the risk premium of the unlevered equity. Right? So that's why you can see that the risk premium of the levered equity is 20%, and the risk premium of the unlevered equity is 10%. So you can see that this is basically the application of CAPM here. Okay, let me summarize this. So basically, leverage increases the risk of equity, right? And you can see that this result actually holds even there is no risk that the firm will default, because you can see that in the second case of financing, right? In the second case, when this entrepreneur is using $500 of debt, we know that there is no risk of default, because you can see that the project will return 1,400 or 900, right? So even the worst case, that is $900, is actually larger than the amount of debt. So basically the debt is risk-free. And you can see that even with risk-free debt, the risk of equity will be larger. And then you would also think about how this would affect your decision to use debt versus equity. So let's go back again to this table here. What you can see here is debt is actually the cheapest source of financing, right? You would only pay 5%. And then unlevered equity is more expensive, 15%. Now you might want to say, well, it looks like debt is cheaper, so I would just want to use more debt. But you can see that there is a cost of using debt. That is, as you use more debt, your equity would become more expensive, right? So in the end, the cheaper debt and the more expensive equity will just balance with each other. And in the end, you will become indifferent in choosing how to use debt and what fraction of debt you would want to use. Okay, now let's see this very simple example here. Suppose the entrepreneur borrows only $200 when financing the project. According to Modigliani and Miller, what should the value of the equity be? What is the expected return? Obviously, we have not discussed these two people, but basically, the assumption of perfect capital market is the main assumption of this Modigliani and Miller. So, according to Modigliani and Miller, essentially means according to our assumption that the capital market is perfect, right? Okay, so let's first ignore this. Let's just say this basically means according to the perfect capital market assumption. Right? What should be the value of the equity be? Well, this is easy, right? So for the first question, we know that the firm has a total value of $1,000. And then we know that instead of using $500 of debt, now this entrepreneur wants to use $200. Now, what is the value of equity? Well, it's pretty easy, right? Equity is just $800. Now second, what should be the value of the, second, what is the expected return of the equity? Remember that from the problem itself, we know that if the economy is strong, the total cash flow or the cash flow generated by the project is actually 1,500, right? Oh, sorry, 1,400. And if the economy is weak, then the project would return 900. And both of these scenarios happen with equal probability. Right? Now let's see how could we calculate the expected return. Well, you can see that if the economy is strong, then what is the cash flow will become, if the economy is strong, then what is the amount of cash flow which is available to equity holders? Well, obviously, the firm has to first pay debt holders, right? Then the residual cash flow will be available to equity holders. So this implies that the cash flow to equity holders will be equal to the total cash flow minus the cash flow paid to debt holders. Clearly here you can see that we know that the firm would borrow $200 and the interest rate is 5%. So this is the total cash flow which should be paid to debt holders. Now what is this number here? Well, let me just copy the lecture note. Now, if the economy is weak, the total cash flow to both debt holders and equity holders would be $900. Still, the firm has to pay debt holders. So the residual cash flow would be okay, so where's the residual cash? Okay, this one. So the residual cash flow would be $600.90, right? Now, how do you calculate the expected return? Well, this is pretty easy, right? Expected return equals your future cash flows, which is 1/2, which is the probability, times 1190 plus 1/2 times 690, divided by your total investment, which is $800. So this will give us some number. I believe it's 17.5%. Okay. Now let's formally talk about the MM theorem, right? So the MM proposition, obviously this is the proposition proposed by these two people, right? Modigliani and Miller. This is actually a very important theorem in corporate finance, and it's a nice and basic result. So let's first formally talk about perfect capital market. We briefly discussed about the three assumptions of perfect capital markets, right? So let's look at these assumptions in a little bit of more details. So the first assumption is, under the assumption of the perfect capital market, investors and firms, they can trade the same set of securities at competitive market price equal to the present value of their future cash flow. Right? So this is essentially the no arbitrage condition. Right? Because under no arbitrage assumption, present value should be equal to the discounted future cash flows. The second assumption is about no tax and no transaction cost and no issuance cost. So this is the, I would say, this no tax assumption is the most important assumption for this chapter, because we will do everything by assuming there are no taxes. And then in the next chapter, you can see that if there are taxes, then how to choose capital structure becomes more complicated. The third assumption is about the firm's cash flows. To be more specific, the third assumption says a firm's financing decisions do not change the cash flows generated by its investment. And what does this mean? Well, this basically means that the performance of your investment is independent of your financing. Or you could say you can use any kind of financing, right? You can use 80% cash, 10% debt, 10% equity. Or you could use 60% debt, 40% equity. But in the end, no matter what your choice is, the cash flows would stay the same. Obviously, you can see that I would say the first assumption and the third assumption, they're actually quite realistic, because first, generally in the financial market, you don't have a lot of arbitrage opportunities. So generally, the market price would be equal to the present value. And for the third assumption, generally, if you're not using a lot of debt, then your investment performance should be indeed independent of your financing. But in the future, you will see that if you're using a lot of debt, then you will incur additional cost, and this cost will indeed affect your investment performance. Okay, clearly the second assumption is not realistic, because in reality, right, we have taxes. That is, if you're a firm, if you have your profit, then you have to pay the government taxes. So the assumption of no tax is not realistic, right? And of course there are transaction costs, right? Transaction costs are universal. You cannot avoid it. And then there are issuance costs. Oh, I think I have not discussed issuance costs. So issuance costs basically mean costs you have to pay when you issue securities. That is, let's say if you want to use equity financing, then if you're a public firm, then you have to issue some equity. In this case, issuing equity requires the firm to pay some cost, right? So it's the same with respect to debt financing. Let's say if you want to use debt financing, one way to do this, you could issue some corporate bond. Again, issuing corporate bond requires the firm to pay some issuance cost. So clearly, by assuming no tax, we deviate from the reality. However, the benefit is we could use this as a starting point, and we could understand what would happen if we are in a perfect capital market when there are no taxes. And by understanding this, right, we will actually get some help. That is, in the future, we will get a better understanding what would happen if we do have taxes. Right? So this is a nice starting point, even it is not realistic. Okay, what is the MM theorem about? Following the textbook, the MM theorem has two components. The first is the proposition 1, right? So MM proposition 1 basically says if the capital market is perfect, the total value of the firm is equal to the market value of the total cash flow. And the total value of the firm is not affected by its choice of capital structure. You can see that this result is actually pretty easy to understand, right? So what this result essentially says is the firm's value equals the present value of the firm's cash flow. And the firm's value does not change by capital structure. And so that's the basic result here. Now, how do you understand this result? Well, just go back to this. Let's just go back those assumptions, right? Now, let's see how could we get this proposition 1 under those assumptions. It's actually pretty simple. We know that by assumption 3, capital structure does not change your total cash flow, right? But we know that firm's value is essentially the present value of the firm's cash flow. So if capital structure does not change firm's cash flow, then it should not change firm's value, right? So it's actually pretty simple, right? Okay. So we basically will discuss several examples. And to discuss those examples, so let's first define the market value balance sheet. And if you're from accounting, you would see that this definition here is actually pretty easy to understand. So what is the market value balance sheet? It's a balance sheet which includes intangible assets such as reputation, brand name, or human capital that are missing from the standard accounting balance sheet. This part is not super important. What is the most important part of this definition is market value balance sheet uses current market values rather than historical cost, right? You can see that this is the main difference here, and this is exactly why it is called market value balance sheet, because if you're just talking about balance sheet, then we know that you're using historical cost. And similar to the basic accounting equation when you're having the balance sheet, we know that if you're having this market value balance sheet, then the market value of equity equals the market value of asset minus the market value of debt. This is easy to understand, right? Because we know that the basic accounting equation tells us asset equals equity plus debt. This is correct for this typical accounting balance sheet. And it is also correct for the market value balance sheet, which means equity equals asset minus debt, right? So equity, so the market value of equity equals the market value of asset minus the market value of debt. Okay, now let's see this example here. Suppose our entrepreneur decides to sell the firm by dividing it into 3 securities: equity, debt, and warrant. Well, clearly we don't know what's this warrant is about, right? We don't know what is a warrant. But can we solve this? Well, we can actually solve this problem without knowing what exactly is a warrant. So this warrant pays $210 when the firm's cash flow is high, and nothing when the firm's cash flow is low, right? Suppose the third security is fairly priced at $60. What will the value of equity be in a perfect capital market? We know from previous lecture, we know that the firm's value is $1,000, right? So we know that the firm's value is $1,000. And now this firm is separated into three parts. The first part is equity. Second part is debt. Third part is warrant. And we know that the debt has a value of 500. And warrant, it is fairly priced at $60. So we have 60 here. Now what is E here? So it's 440, right? So the value of the equity in a perfect capital market is 440. This is basically a direct application of of this result here, right? Okay. Now let's talk about this application here. It's called a leveraged recap, right? So what is a leveraged recapitalization? So if a firm is borrowing money, and then if the firm uses the borrowed money to pay a large cash dividend or buy back its own shares, then this is called a leveraged recapitalization. So you can see from the name, right? It is called leveraged. Well, because the firm is borrowing money. It is called a recapitalization because the firm is changing its capital structure. For example, if the firm uses borrowed money to buy back its own shares, this is essentially saying that the firm increases its fraction of debt and it reduces its fraction of equity. Right? So this is a change of its capital structure. So this is a recapitalization. When you're doing recapitalization with debt, with borrowed money, then this is a leveraged recapitalization. Now let's see this example here. So we have a firm which is a all equity firm in the beginning, right? It's an all equity firm. And it has 50 million shares outstanding at $4 per share. And this firm increases its leverage by selling debt to raise $80 million. That is, the firm borrows $80 million. Then it uses the cash to repurchase 20 million of its outstanding shares at $4 per share. So now our question is, how many shares, right? How many shares will be left on the market? And what would the firm's capital structure look like after this recapitalization, right? Now let's solve this problem. Okay, so I will just draw out its market value balance sheet. So the problem says in the beginning, the firm was an all equity firm and it has 50 million shares and the share price is $4. So you can see that this implies the equity, right? The firm's equity has a value of $200 million. And this is an all equity firm. So this firm does not have debt. This implies the market value of asset equals its equity, right? So in the beginning, firm's asset, firm's equity, both have a value of $200 million. And we also know that the firm has 50 million shares, right? And the share price is the share price is $4, right? So we have number of shares, 50 million shares. Now, the firm increases its leverage by selling debt to raise $80 million in cash. Now, how the market value balance sheet should change? Well, you can see that what would happen is, first you can see that the firm's equity should stay the same, right? Because after borrowing money, after borrowing $80 million, the firm still has $4 stock, and the number of stock is also 50 million shares. But now the firm will actually have what? It will have leverage, right? And the value of the debt is $80 million, right? So you can see that the firm's total asset would become $280 million. Now, how do you divide this firm's asset? Well, you can divide this firm's asset into two components, right? The first component is cash, which is $80 million. And then the second component is existing asset, right? That is asset here, right? So we have a existing asset, which is $200 million. Next, the firm starts to use its cash to make the repurchase. So let's see how the firm's market value balance sheet would look like. Okay, wait, let me draw a smaller rectangle. Oops. Let's see what would happen here. So you can see that the firm decides to repurchase 80 million of its shares. So obviously the number of shares would be 30 million shares, right? Now what would happen to the firm's equity? You can see that before the repurchase, the market value of the equity was $200 million. But now the firm actually repurchased 20 million shares at $4 price, which means 20 million shares would be disappearing from the market, right? So this implies now the value of the equity would actually become 200 minus 80, right? So this is the original market value of equity. 80 is the amount of equity retired from the market through the repurchase. So in this case, you can see that I should put a number of 120 here. Now, what about debt? Well, the firm has not paid back its debt yet. So the amount of debt is still the same, $80 million, right? So what about the asset? Well, obviously the market value of asset would be 200, right? So what exactly happened is you can see that the existing asset will still be here, right? Existing asset would still be $200. And what would happen here is if you look at the second market balance sheet, you can see that what is happening here is this cash would disappear, right? Because the cash will be used to make the repurchase. So in the end, we would see that the firm's market value would return back to $200 million. And you can see that the firm's leverage would increase, right? Because previously, if you look at the first graph here, right? If you look at the first market value balance sheet, it's an all equity firm. And after this repurchase, you can see that Now it has a mixture of debt and equity. So basically, this tells you the leveraged recapitalization is a method for the firm to change its capital structure, that is, to change its use of debt. And another thing is you could, we still haven't figured out what is the stock price after the repurchase. Well, you can see that this is pretty simple, right? We know that the market value of equity is given by 120. And we know that there are still 30 million shares left in the market. So you can see that the price of the stock would stay the same. That is, price equals 4. This is actually a particularly important result, at least in our lecture. So let me emphasize here. If we have a perfect capital market, then leveraged recap will not change the firm's stock price. In the future, you will see that in a different scenario. If we are doing a leveraged recap when there are taxes, then leveraged recap will actually increase firm's stock price. So this is important for you to remember, right? You don't make mistakes in your exam because a lot of people have made mistakes in the past. Okay, now this table is essentially the replication of the table we just drew in on this page. So I mean, obviously it's in a nicer format. It looks much nicer, but it's essentially the same. Okay, that's for our example here. Now let's talk about proposition 2. Proposition 2 is basically derived based on proposition 1. Remember that according to proposition 1, the firm's market value of asset equals the firm's market value of equity and its market value of debt. So by using notation, we could have a result as this. So what is U here? So this guy is the market value of equity in an unlevered firm. That is, if we assume the firm is an all equity firm, right? So we basically have this result about different market values. And based on this result, that is, if we know that the market value of E plus D equals the market value of the unlevered firm equals the market value of the firm's asset, then we would know that the return, right? The return of the firm's asset equals the return on the firm's unlevered equity. And then we would also know that we can consider the firm's asset as a portfolio of equity and a portfolio of debt. So this implies we should use what we have learned about portfolio weights and portfolio return, right? So on the left-hand side, we should have something like this. Right? Again, let me repeat, how do you get this result? According to proposition 1, we could show this formula holds. And this formula essentially tells us we could consider the a firm's asset as a portfolio of its equity and debt. So we could use what we have learned about portfolio returns to calculate the return on the firm's asset. So basically the return on the firm's asset is the weighted average of the firm's return on equity and the firm's return on and the firm's return on debt. So we could get this result here. Obviously, this is sort of like a proof, and proof is never required. What you need to know is this relationship. Okay. Okay. And from this result, we can find out an important result on the cost of equity. So let me derive this here for you. So this is our starting point. And this would imply right? It's just a basic algebra. And now you can see that E times RE equals RUD plus RUE minus D times RD, right? And this implies RE equals RU D divided by E plus RU minus RD D divided by E, which is RU plus D divided by E RU minus RD. So now we basically have solved this result. And this is the proposition 1, right? Sorry, this is the proposition 2. So let's look at this formula here, and you can see that what is this RU? Well, this RU is the return for the risk without leverage. Why this is without leverage? Well, because RU is really the return of unlevered equity. When you're talking about unlevered equity, then obviously there is no leverage. And then this represents additional risk because of leverage. You can see that if D equals 0, that is if there's no debt, this whole term would be just 0. And you can see that, and you can see that most of the cases, as you increase D, right? As you increase D, this whole term will increase. Right? This is equivalent to say that as you increase your level of debt, then the additional risk due to leverage will be higher. Right? Okay. So to put this formally, proposition 2 basically says the cost of equity of levered, the cost of capital of levered equity increases with the firm's market value debt equity ratio. Okay, now let's do a very simple calculation. Remember from the previous example, the entrepreneur's firm, right? Its unlevered equity has a return of 15%, and its debt has a return of 5%. And we also discussed the case when the firm is financed with 500 of debt. Now, what is the cost of equity? Well, it's just RU 15%, D divided by E, and RU minus 5%, right? So what is D divided by E? It's just 500 versus 500. And RU here is obviously 15%. So this gives us 25%. Okay, let's check this answer with our example from the first lecture, right? You guys can see these numbers from this table, right? You can see that this is RU and this is RD. So our question is, how do we get this guy? And what is D and E here? So this is E, this is D. And you can verify that obviously 25% equals our U, 15% plus 500 divided by 500, and 15% minus 5%, right? So you can see that this table basically shows us MM proposition 2 is correct. I mean, obviously, of course it is correct. Okay, let's see this example here. So suppose our entrepreneur borrows only $200 when financing the project. According to MM proposition 2, what will the firm's equity cost of capital? So you can see here, let's first find out what is the value of the firm's equity, right? We know that this entrepreneur's firm has a value of $1,000. So if the value of the debt is 200, now you can see that equity, right, gotta be $800. Now we want to find out the firm's equity cost of capital using MM proposition 2. So we would use our E equals our U plus D divided by E times our U minus our D. So what is our U? Well, we just look at that table and we know that our U is 15%. So D divided by E would be 200 divided by 800, and 15% minus 5%. So this would give us a number of 17.5%. So if we compare this case, right, with this case, you can see that the only difference under these two cases is the amount of debt. And you can see that when the amount of debt was $500, then the equity cost was 25%. And now if we reduce the debt from $500 to $200, the cost of equity would reduce from 25% to 17.5%, right? Okay, now let's talk about the weighted average cost of capital. So we basically have defined the weighted average cost of capital, right? We know that WACC equals this, right? 1 minus the corporate tax. Now we're assuming the capital market is perfect, which means the corporate tax rate is just 0, right? So we could just remove this part, right? We could just remove this part. And we also have learned this is just the unlevered cost of capital and the firm's asset cost of capital, right? So you can see that if the capital market is perfect, then weighted average cost of capital equals RU equals RA. And we know that the unlevered cost of capital and asset cost of capital, they're not affected by the firm's capital structure choice. So this basically implies that if the capital market is perfect, a firm's WACC is independent of its capital structure. So let's see this picture here. Now you can see that WACC, which is given by this yellow flat line, is flat, right? It basically means Oh, first let me introduce this picture, right? The vertical axis gives you the cost of capital, and the horizontal axis gives you the debt to value ratio, right? So here you can see that as you increase your debt, right? That is, as the debt to value ratio increases, WACC stays the same. Obviously, this is the result that WACC does not change with your capital structure. However, you can see that the equity cost of capital always increases, right? This is very understandable. This is just the result of MM proposition 2, which says if you increase the amount of debt, then the risk of your equity will increase. This implies the equity cost of your capital will increase, right? So that's why you will see this RE always increases with the debt value ratio. And you can see that the debt cost of capital, RD, has the interesting pattern, right? Here you can see that if debt was actually below 50%, then the debt cost of capital, RD, is essentially flat. It keeps at 5%. Oh, this is easy to understand. This is because if the debt level is low, then there is no default cost. So investors, they will not require a higher compensation because of the default cost, right? But if your debt is sufficiently high, there will be default cost. In this case, investor will require some compensation, right? This implies if you have a higher level of debt, then the cost of debt will become higher and higher. So that's why you could see that the debt cost start to go upward after this 50% debt value ratio. Okay, now let's see this example here. So Northern Alberta is a natural gas firm. The market debt equity ratio of 2. Suppose its current debt cost of capital is 6%, and its equity cost of capital is 12%. And we suppose that this firm issues equity and uses the proceeds to repay its debt and reduce its debt equity ratio to 1. And this will lower its debt cost of capital to 5.5%. With perfect capital market, how would this transaction affect the firm's equity cost of capital and its WACC? Okay, so how do you solve this? So this problem, so let's start with WACC. Right? Let's start with this guy here. So we want to find out what is the firm's WACC after this transaction. However, we have learned that under the assumption of the perfect capital market, the firm's WACC stays the same, no matter what is this firm's capital structure. This implies we could find the firm's WACC before this transaction, and we could use the WACC before the transaction as our answer. Right? So let's say we want to find out the initial WACC. And we just learned the formula for WACC is like this. How do you find out E divided by E plus D? Well, we know that debt equity ratio is given by 2. So this implies E divided by E plus D equals 1/3. How do you get this? Well, if D divided by E is 2, this basically says D is 2, E is 1, right? So that's why E divided by E plus D equals 1/3. So 1/3 times the cost of equity, which is 12%. So 12% plus 2/3 times the cost of debt, which is 6%. So this gives us 8%. Right. Okay. Now, next. Right. We've just found. We have only found the initial WACC, right? And we know that the current WACC after the transaction equals the initial WACC. So the answer is the WACC is just 8%. Now, what about the equity cost of capital after this transaction? Well, here we would use this result. And what is our U? We know under the assumption of the perfect capital market, our U equals WACC. So we could use WACC here. Okay, now we could plug in numbers. WACC is basically 8%. And debt divided by equity. So we could see from the problem that after the transaction, the firm reduces its debt equity ratio to 1. So we have a number of 1 here. And then times WACC, which is again 8%. And after the transaction, the debt of cost of capital is 5.5. So we have 8% plus, I think it's 2.5. So 10.5%. Let me check the answer. So yeah, after the transaction, the equity cost of capital becomes 10.5%. And also you can see that before the transaction, when the debt equity ratio was 2, the equity cost was 12%, right? And after the transaction, the debt equity ratio has been reduced to 1. And then you could see that the equity cost of capital also reduced to 10.5%. Again, this is just very natural, right? This is exactly the result which would be predicted by the proposition 2. That is, lower debt, then you will have lower equity cost of capital. Okay. Okay. Now let's look at another example. So you can see that when we were trying to define WACC, we pretty much assume the firm has only 2 sources of financing, right? Either debt or equity. However, in reality, the firm could have more than 2 different types of sources. So if the firm's capital structure is made up of more than 2 types of securities, then the calculation of the WACC is actually essentially the same, right? You will still compute the weighted average cost of capital of all these firms' securities. So let's see a example here. Compute the WACC for the entrepreneur's project with the capital structure described in example 17.3. And you can see that here I have copied the example 17.3 here. So the problem is basically like this. The entrepreneur could finance its firm by using 3 securities: equity, debt, and warrant, right? And we also know that the amount of debt is 500, and then the warrant would pay 210 if the cash flow is high and nothing if the cash flow is low, and the warrant would have a price of 60, right? Now, How do you calculate WACC? So you can see that we know that we have 3 securities. So basically we will use a more complicated form of this weighted average, right? So equity divided by equity plus debt plus warrant times the cost of equity, and plus debt divided by the sum of all the 3 securities. E plus D plus W R W. Here W refers to warrant. Let's see what kind of numbers do we have here. We know that D actually equals 500, right? And we also know W equals 60. So clearly E equals 440, right? So this is pretty simple. Now what about RE? First, we know RD, which is easy, 5%. And we actually don't know what is the RE here, right? So what is RE? Well, we need to find out this number, right? So we need to find out RE. And we also need to find out RW, right? What is the return? What is the expected return on our warrant? Now, how do you find out this? Well, first, RW is actually pretty easy to calculate because we know that the warrant will pay 210 and nothing, right? If the economy is strong, the warrant will pay 210 if the economy is strong and nothing if the economy is weak. So in this case, you can see that RE equals 50% the economy is strong, 50% the economy is weak, divided by the price of the warrant minus 1. So this is 11060 minus 1, which is I don't know. So what's the return of the warranty here? So it's 70. Oh, sorry, it's not 110. It's actually 105. So it's 75%. Right? So we could calculate the expected return of the warranty is 75%. Now, what about the expected return of the equity here? This is slightly harder, but it's still pretty easy. So we know that if the economy is strong, the firm's total cash flow is 1,400. And then it has to pay back the debt, right? It's 500 times 1.05. And it also needs to pay back the warranty holders, and the amount would be $210. This basically means the equity holders will get 665, right? If economy is strong, and then the percentage or the probability is 50%. And if the economy is bad, the total cash flow would be 900. Still, we have to pay back the debt holders. And then in this case, we don't need to pay the warranty holders. So it's just a 0. And in this case, we will have a number of 375. Yeah, 375. Right? So in this case, economy is weak and happens with 50% chance. So what's the return? What's the expected return of the equity? Well, 50% chance times 665 plus 50% chance times 375 divided by the value of equity. Well, we know the value of equity, right? It's just here, 440. So divided by 440. And this gives us a number of 18%. Right? So we have 18.18%. So basically now we have obtained all data points which are needed to calculate the WACC, right? So next, let's just plug in numbers. RE, which is 18.18%, 500, and RD would be 5%, plus so the return of the warranty would be 75%. So this gives us a final number of 15%, right? And you can see that this number 15% is expected. Why? Because we know that if the capital market is perfect, then we know that WACC equals RU, right? What is RU? And we have learned the return on the unlevered equity is just 15%. So obviously WACC should be 15%. So this calculation here basically confirmed WACC equals the unlevered cost of capital. Okay. So finally, let's talk about levered and unlevered beta. And we have learned about this, right? From previous lectures, we have learned the unlevered beta equals the weighted average of betas of individual components of the firm's capital structure. That is, beta U equals the portfolio weight of equity times the beta on equity, and the weight of debt times beta on debt. And we could actually manipulate this formula and get this important result, right? So let me show you how do you do the algebra here. Again, this is not, again, the algebra part is not required. So this essentially means E plus D times beta U equals E beta E plus D beta D. And this implies E beta E equals E beta U plus D beta U minus D beta D. So this implies beta E equals beta U plus D divided by E beta U minus D divided by E beta D, which is beta U plus D divided by E beta U minus beta D. So again, you can see that this is essentially the proposition 2 in the form of betas. Remember that in the original version of proposition 2, we were talking about cost of capital, right? So we were talking about this. Oops. So this is proposition 2. And we know that if you have more debt, then you can see that the cost of equity will be higher, right? And you can see that this formula here explains exactly why. Because you can see that if the fraction of debt increases, then you can see that beta of equity actually increases. That is, as you increase the amount of debt in your firm, then the systematic risk of your equity will be higher. And according to CAPM, of course, the cost of equity will increase if you have more debt, right? So you can see that these two formulas, they are actually very tightly related with each other. Okay, that's for today's class.